about the business side and the strategy we've put together in standing up a quantum program in a very large-scale global organization. And then at the end, I'll touch a little bit on some of the technical work that's come out in our brief lifetime. Okay, so to start, we've come up with an organizational strategy to be able to stand up our quantum computing program. And central to this strategy is being able to develop internal engineering excellence. So to be able to do that, we hired external quantum information scientists like myself. And we're trying to look at use case development, developing new types of applications, and doing research in this space, and working with business lines to be able to drive quantum applications forward within the group. And then, of course, we talk about organizational readiness. So with an organization of 240,000 employees, a few quantum information scientists aren't going to be able to do everything on their own. So we are working with business lines to be able to develop technical readiness. So this is through training programs, being able to, teach these business lines working in quantitative rules, how quantum algorithms work, how they might apply to their workflows, as well as on the business line. So it's actually really interesting. Sometimes I enjoy talking to frontline bankers who are really interested in quantum computing and actually want to learn more about it. So being able to have those conversations within the group, which gains support for our team. And then finally, we're not able to do this without strategic partnerships. So we work with startups as well as hardware providers and making some investments in quantum startups to be able to substantiate our use case development. And at the end, our mission statement is to unlock competitive advantage with quantum computing, which is what we're all here to do. So I'm preaching to the choir, but this is how we intend to do it. So to take a look at the timeline, we have prioritized our use case development based on technological readiness. So if we look on the left-hand side, you see quantum technology that is product ready today. And this is like quantum random number generators. These are, not algorithmic random number generators, but based off of hardware with potential to have verifiable quantum randomness. And we want to see how maybe we could use these within our organization. We could look at hybrid quantum simulation. And in this case, I'm really talking about quantum-inspired algorithms, matrix product states, to be able to see if we can actually use these within our workflows. Do we get better improvements, something to benchmark against? And then, of course, quantum key distribution, where this is a repeaterless network, and we're working with trusted nodes. And then as we look to the future, right, so our use case development really falls on the left-hand side of this chart. But on our research team, of course, we're looking farther into the future to be able to prepare for fault-tolerant quantum computing, thinking about what distributed quantum computing might look like, as well as full-scale quantum network development. So I'm sure everyone is pretty familiar with the standard bins of quantum application research, which is optimization, machine learning, simulation, and improved security. So of course, there's like a laundry list of potential use cases that we're all seeking to develop underneath these categories. And within our portfolio of use cases, we're trying to span all 4 of these categories. And I would say this is kind of a prudent effort at this point. Of course, we want to think about how quantum information can be used in novel ways within financial services, but at the moment, we're really sticking to some out-of-the-box types of techniques, especially related to like optimization and machine learning. So as I mentioned, I'm going to talk about like kind of our strategy. So once we started to gain some traction internally within HSBC, as well as externally, we had just a laundry list of use cases pouring in from around the globe. And people wanted to think about how they could use quantum computing within their organizations. So the top 2 criteria, so we actually came up with a quantitative model to assess these use cases and rank them to be able to pick the ones that were going to be hopefully deliver the most valuable and be most achievable on a near-term horizon. So the top 2 are based off of kind of business priority, customer priority. So business priority is like, do we see that this use case could actually bring in revenue, generate new revenue, or save revenue within our organization? This is, of course, probably the most motivating to leadership in terms of pursuing a use case. The second criteria is around customer priority. So, if we were able to have this quantum application, would it make our customers' experience better? Would we be able to offer better products to our customers? And on the bottom, this is more technical, right? When we're trying to be able to evaluate these use cases coming in. So what I think is kind of fun is classical maturity. So you hire a bunch of quantum scientists. They're like, okay, you've hired all these smart people. Let's send all of our hard problems to you guys, because clearly you can know how to solve them. So sometimes we've gotten use cases where there's actually no mathematical model underpinning the problem they want to solve. And so that's like priority number one. Like, do you have a well-established mathematical model behind the problem that you want us to solve? Therefore, you would get a high rating. If you just say, like, can you solve our, climate risk within certain areas, but we have no model for how we're going to assess climate risks, we're going to be like, no, like, this is not for us. The next one, which is quantum feasibility, that's really about like the readiness of the technology. So for instance, a near-term quantum computer maybe, quantum-inspired QKD, those score a little bit higher, whereas like fault-tolerant quantum computing would score lower in this area because we know that it's going to be a while till we actually have fault-tolerant quantum computers. And the bottom one, that's quantum maturity. That's like, can we take an algorithm out of the box? Has this already been developed and applied in the quantum case? This is something that would kind of make our lives easier and being able to kind of benchmark and see how this will work on a use case. So of course, in this case, I want to mention that I'm really talking about use cases here and working directly with business lines to see how quantum can be used in their workflows. So this is not really how we assess ourselves on our own research pursuits, where we actually might go a little bit deeper and think about preparation of difficult distributions or trying to come up with new types of ideas with quantum in financial services. So these are our projects in motion. Again, I mentioned I joined about 6 months ago. This is a brand new program spun up within the last year. And so we went through this ranking algorithm and we prioritized these top use cases, working directly with business lines, cybersecurity, wealth and personal banking, global trading and receivables, markets as well. So we're working directly with those business lines and having partnerships with either hardware providers or software providers to be able to identify whether or not we can have business value in the near term or the long term within these areas. So the top one, which is quantum key distribution, and I was happy to hear about JP Morgan and what they've been doing in terms of developing QKD networks. We're also partnering with a telecom company and installing these devices within our wealth centers and data centers and are going to be able to do trials of sending classical information and quantum superposition between our actual sites. And you can imagine the compliance that goes in to be able to install something like a quantum device internally. So I guess we're setting precedent for how we might do this in the future. The next one, which is what I'm working on, this is with IBM. And we're looking at transactional fraud detection. So this is really out of the box, binary classification algorithms for UK digital transaction data. And we're really just looking at benchmarks against what the fraud team is currently using within their organization from an ML perspective to see if quantum can provide a little more interpretability or improvement in precision or AUC. Of course, optimization is a big one. You've heard about this from several people. And so we're looking at two different use cases, one with MSS around collateral optimization, and another one with global trading and receivables. So what's interesting, and I know a lot of the banks talking today also are global operations, but HSBC really has a lot of influence on the supply chain. And so we're actually looking at how maybe we can frame a new application in the space of pricing for our supply chain. And this would actually impact the products that we could offer our customers. And then at the bottom, and I really want to highlight this because this is something that I think is interesting, especially talking to people from academia and other partners, is we received an Innovate UK grant to work with Quantum Dice as well as Hartree to see if the quantum random number generators from Quantum Dice with verifiable quantum randomness can potentially improve the accuracy of Monte Carlo simulation. So I kind of want to highlight that we did this actually through a government grant, and that is something that we're interested in pursuing and partnering with startups and with academia to be able to drive research and development. So I kind of want to talk about, all right, we have these use cases going on, we have researchers hired, but in the end, we need to be able to report up to our leadership. And we're a commercial finance bank and with a really low risk tolerance. So we need to be able to show some sort of value to our leadership in a way that they see is valuable. And as you can see, the lowest of priority is papers. Which as coming from an academia, national lab setting like myself is always the highest priority. So you kind of have to flip that on its head. We also have done white papers with global research, and this is all very fun, but in the end of the day, our leadership wants to be able to see value. So you can quantify this in terms of like soft value. This is like patents, trying to get patents out there, again, the publications, but they really want to see hard value. And when we look to fault-tolerant quantum computing, I think that hard value is a ways off. And so I would say we're actively looking at how can we improve, maybe with quantum-inspired, to be able to deliver some returns on the work that we're doing. Because in the end, just a little bit of improvement in precision can equal many millions of dollars across the group, either within a region and particularly when we're looking at something globally. So to end, I'll highlight a little bit of research that's come out. This is currently on the archive and being submitted to journals. So on the left-hand side, this was also an Innovate UK grant with the University of Exeter to explore how unsupervised machine learning algorithms can be used to detect anomalous behavior and fraud. And so they looked at quantum kernel methods using a public data set, a Kaggle credit card transaction data set. And they were really comparing apples to apples. So they were looking at quantum kernels with a ZZ feature map, pretty out of the box, and comparing that with classical kernels and support vector machine. And what they found is that as you increase the number of features, you're actually able to see an improvement in precision, which is optimistic. But of course, we want to take this a little bit farther. This is my research right now. And we want to move away from just working on public data sets and actually think about, if we were to integrate this with our real HSBC data, how would these algorithms work? And we're not just going to compare apples to apples. We want to compare apples to best in class, which is usually like XGBoost algorithms. And we're also really not looking at the unsupervised space. So there's a compliance aspect of using unsupervised machine learning algorithms and fraud, specifically related to interpretability. So at the moment, what's being used in the pipeline is binary for classification. So that is where we focus our efforts, because if we were to actually show some sort of advantage, we'll say, using quantum, we want to make sure that it's actually going to be integrated within the bank and actually within their risk tolerance. On the right-hand side, this is some work that came out in collaboration with the Czech Technical University and Georges, who's on our team. And they were looking at using the Pentagon equation to be able to transpile quantum circuits related to the Heisenberg spin Hamiltonian. And what they found is that they were able to get circuit compression by improving the locality of Pauli operators on these Heisenberg models. So if we think about, we can think about like loading classical data from a quantum setting, or classical data from a financial setting onto a quantum computer, but we also think about how can we represent some of these quantum problems, classical problems in a quantum framework using these Heisenberg or Pauli Hamiltonians. So this might be a nice application in that area. And with that, I will end. Thank you.
Thank you. Thank you, Mekena. Any questions from the audience?
Yes, on one of the slides, I'm Dan Ballou from Deloitte. I saw that it said quantum system demonstrating value, business value. I was just curious if you could elucidate on that.
Yeah, I mean, that's the goal, right? So what is that quantum system? I would say like the quantum random number generator would be within that area. Potentially a near-term device if you just throw everything you can at it to make your circuits better. We heard about Fire Opal. Maybe we can be optimistic and using control to make our qubits work a little bit better. I also kind of think about with these analog quantum simulators, is there something that we can do in that area that's like quantum systems to demonstrate business value? The issue with analog simulators is there's no algorithmic guarantee of precision, which is really hard to explain in terms of compliance. But the goal, or quantum inspired, which isn't really a quantum device, but our leadership, as long as we're making them money, they're very happy.
Okay. Any other questions over here?
Hi, Mekena. I was interested in hearing a bit more about the pricing optimization using digital annealers, the dynamic pricing optimization that you mentioned in one of your slides. Thank you.
Yeah. So right now, that project is in discovery. We haven't spun up, so we don't have any interesting results to talk about at this point. So the goal is to be able to represent some of these problems that we have in terms of looking at a global ecosystem, representing it as on a Kubo Hamiltonian and seeing whether or not we can do better. But this is actually something where I think it's actually kind of a new area, and so I'm curious to see what they're going to be benchmarking against in terms of, are they benchmarking against classical optimizers, but in some essence they're kind of creating a new application in this space. And I think that was the excitement around that, is it was something that made sense to represent by a Kubo Hamiltonian. And so that's what they're looking at. But I don't have any results to talk about in that case.
Okay. One last question.
Yeah, thank you. I wanted to know, how do you collaborate with academia? How does it go with the HSBC lab? Do you propose use cases and they do papers, or the other way around? Thank you.
Yeah, I would say that's an that's something that we're exploring, and so that I'm trying to get a better handle on. What is the optimum way to collaborate with academia? I think in this case we come up with research ideas, right, together, and this supports a use case that we can validate within the bank. Maybe we're using an algorithm that's been developed in academia. We want to see how it's actually going to try in a research setting, and we actually try and seek out external funding for that. If we can show some interesting results, we can get out a good paper, then we can even think about using our own internal funds to be able to support academic research, specifically in the UK in this setting, but also looking at that here in the US.